Okay, hello everyone, welcome to Warm Sphere, and this is the very last part of Warm Summary on reinsurance. Okay, so in this part, we're just gonna have a look at one problem that would be nice for test your understanding for this chapter. Okay, so here is the selected problem. Okay, the problem is about the problem a given that the claim have the original claim, so we just note that. Okay, the original claim will follow log normal distribution with mean and standard deviation, so we don't know yet what is mu and sigma square. We just know that mean and standard deviation is 9.07 and 10.132. Okay, and then in any 1 year 20% of policy I expect to give a right to a claim, so let's highlight that a little bit. 20% will give a right to a claim, so the rest of them will have no claim. Okay, the insurance company have 200 policy on its book. Okay, and then there are two options for direct insurer to do insurance. So they might do with retention limit of 25 or retention limit of 30. Okay, so let's see what we have to do. What are the asked? First one, where they ask that the probability under each insurance arrangement that the claim arise will involve reinsurance. Okay, so this is the first one. So we have to find the area of log normal, which couldn't be done if we haven't know the parameter. So the first step is to solve for the parameter mu and sigma square, right? So expectation of x will be given by, as shown, as you may have a look in a table, is mu over plus 1 over 2 sigma square, and this is 9.07. And for variance, the table will show formula for variance, but this one we are given standard deviation, so we just take square root of variance, and the formula that we have is e to the power of mu plus half of sigma square multiply square root of e to the sigma square, take away 1, and this one is given to be 10.132. Okay, so we have two equations. We have this first equation and this second equation. Okay, and then we solve for parameter. So you may notice that if you multiply the second equation by the first equation, if you left you with just square root of e to the power of sigma square, take away 1, equal to whatever they divide into, 10 plus 132 over 9.07. So I left you the calculator stuff, and after you solve for this one, you should get sigma square equal to 0.81. Okay, and then you just plug this number back into the equation, then you should have your mu equal to 1.8. Okay, so let's continue. The question for number 1 here just asks for the probability. So for treaty of excess of 25, okay, for excess of 25, the probability that the reinsurer will involve is probability that x greater than 25, right? And this is probability that the standard normal is will have a value of greater than log to 25, take away 1.8, and then divided by 0.9. right? And after you're done with calculator stuff and open a C table, you should get around 5.75%. Okay, and for excess of 30, thing gonna be the same, so I will just skip it. Thing gonna be the same here, and you finally got 3.76%. Okay, now let's move to the second part, the part 2, part B. Okay, this is part A, then part B. What they ask for part B? Part B, they ask which option of reinsurance, which retention limit option will give the best value for money. Okay, so the idea here is we have to find expect payoff from the reinsurer per one unit of premium that we are going to pay for the reinsurer, right? So first, we will find the expectation of payout from reinsurer in each case. Okay, let's start from the excess of 25. Okay, for excess of 25, the expect payout by the reinsurer, let's call R. Okay, gonna be, let's call that, so it's gonna be the same for the whole book. Okay, gonna be integral from 25 to infinity of x take away 25 fx and dx. Fx here have log normal distribution, so we could deal with this one by using the formula in part 2 of this series when we're working with log normal. So we break this part into two parts. So it have 25 to infinity of x fx dx. Take away 25, integral from 25 to infinity of fx dx. Okay, and to do this first part gonna be the part where k equal to 1 in the formula. So we have e to the power of mu plus sigma square over 2, which is 0.81 over 2. Okay, and then the upper part is infinity, so we have 1 take away phi of log 25, take away 1.8, then divided by 0.9, then take one more sigma away, right? So it's this one. Okay, all good. This is the first one, and the second one is 25 of the case where k equal to 0. So we just have this one, log 25, take 1.8 over 0.9. Okay, so all of them is left to be calculated by the calculator and the C table. So I will skip the calculation part. You may do it yourself, and let's see if we got the same number. I got 0.824. Okay, and for excess of 30, it's gonna be the same thing, so I will show just the part where the excess of 25. For excess of 30, expect payout by the reinsurer will be 0.592. Okay, and this expect payout for each policy. Okay, so now let's move on to the part where we consider which one is more best value for money. So we have, so let's begin with the excess of 25. Okay, the excess of 25, we have 200 policy in our books. 20% of them gonna give claim, and for each claim in our book, reinsurer are expect to pay 0.824. Okay, and for having reinsurer paying for this, we have to pay them 48.5. So after we calculate this expression, we're gonna have the expected payout by reinsurer per 1 unit of our premium, and this gives us of 0.6796. For this one, excess of 30, we do the same thing. Over the premium, 38.2, and we have 0.6199. So to make a choice, the first one, the retention of 25 gonna make the better value for money. Okay, then move on to the last question, the part C. Part C, this one. Okay, we assume all other things are equal. That equation increase the mean and the standard deviation of a claim in this portfolio by 8%. Okay, so if reinsurers still charge the same price as before, so we have to just reconsider under this new circumstance which one gonna be the more which one gonna be better value for money. Okay, so first of all, the parameter gonna be changed. Okay, so let's have comment here a little bit. This one gonna rise by 8%, this one gonna rise by 8%, and then the way we solve, we divide them. So this 1.08, the inflation thing gonna cancel out, so the sigma square gonna be the same, right? So our sigma square will remain the same, but instead of plugging this into this equation, we have the new one, right? We have this one instead. Okay, so calculating from this one instead, because the mean have rise by 8%, and this one gonna give you a new mu equal to 1.877. Okay, now we just repeat the same thing as we have done in part B. So expect offset in case of excess of 25, in excess of 25, expect offset gonna be 1.0166, and excess of 30. This one had expect payout by 0.738466. Okay, or 85. Okay, now we consider the same thing here. 200 rise by 20%, each of them, reinsurer expect to pay 1.0166, and we pay for this policy for 48.5, and this give the value of 0.8384. The other one, 200 multiply 0.2, 0.7385 over 38.2. This one gives 0.7733. So, conclusion, still the excess of 25 policy still give a better value of money. Okay, so we have finished this series, the warm summary on reinsurance, and thank you very much.